What's up, guys? I believe it is episode 6 for the Time Attack build. Basically this week we did a lot of sheet metal work. We made some fenders that weren't there previously. We mounted the rear wing. I apologize for being up in your face. Jarrett from Racing assured me that it would be better. So there's your shout out, Jarrett.
All right, guys, we've been seeing a lot of messages on Instagram and Facebook about the fender liners. So I'm going to show you basically how I'm going about building them, because we can't make this a production piece. It's far too custom specifically for this wide body, and I just don't know how we'd make it manufacturable for anybody but having you do it custom. So I'm going to show you how I do it. You can do it yourself. We'll see what we can do, but here's the process, I guess. Lucky for me, the other side, so I kept this piece from the other side, and it actually lines up really well. So I've actually already created all these tabs for the most part, and as you can see, it slides in there pretty nicely, curls around, and then that'll go like so. But the top part, I wanted to create something a little bit different because I want to make it better on this side. The other side, I'll just add another piece, but I'll show you. So basically, I just grab a piece of cardboard and I start cutting right here. So I cut that to fit over there, and then I hold it up and I create a Sharpie mark to the fender liner, or to the fender. So I basically just go all around with a Sharpie, and I created that line. And then I know that to rivet it to the fender, I'm gonna need about another inch or so, 25 millimeters. So I'm gonna actually do a cut right there, and then we'll mock it up again and then make it out of sheet metal. All right, so at this point, I've cut out the cardboard. You can see that these are the bent edges, about 1 inch, so that I can have some area on the fender to actually rivet it, and everything else lines up pretty well. So now we're going to actually move to the sheet metal part of this section, which is basically drawing out the flat pattern and cutting it out. We have our flat patterns on the sheet metal. Now we're just basically going to use some sheet metal shears to cut it out. I don't have anything fancy to cut metal because we're just not doing it that much, but sheet metal shears works pretty well with this thickness aluminum at least, so that's what we'll do. Alright, guys, we are back. I have bent this in our little press brake, which is basically just a Harbor Freight thing. It's not great, but it does work, and again, we don't fabricate that much. So I'm going to show you now what I do to rivet this into this location. And basically, I start with a single location, and then I will work my way out from there, drilling, then riveting, to ensure that it basically fits as best as it can. I'm also going to stop talking now so that Clay can speed it through it. But yeah, here you go. Oh, and as far as tools, I have a drill, I've got a bunch of rivets, and then I have a pneumatic rivet gun. And that's all that it really takes to do this. Alright, so this is the tricky part, is basically getting these two pieces to line up together. So this is going to take a little bit of work, but now you can kind of see how the entire thing is set up basically to accept this piece, and we'll just figure out how to do that next. Alright, I accidentally forgot to start recording again, but basically I just added another rivet here, another rivet here, and then I've been working on the upper, I guess, 3/4 part of the fender liner to get it to actually fit and cinch up in there like it's supposed to, and then actually attach to this lower piece as well. So now we're going to rivet that.
now that the bottom piece and the other upper piece is connected to one another, we can now basically connect it to the frame. So we're basically going to rivet here, and we're going to rivet to the outside of the fender, and then we'll be good to go. Starting at the front, you can see our sheet metal front fenders. We actually go through the entire build process on basically how I built it. We didn't really get to use any high-tech fabrication equipment because we don't do fabrication here really that often. But realistically, anybody could do this. We're gonna fill this in a little bit more. So we are gonna add another piece there. You can see the prototype ABS thing, and then we're gonna add some more stuff right here, but we gotta wait for our front diffusers to be made first. Moving to the rear. All right, so we have our flat pattern design. We're actually gonna extend this down a little bit, but we'll do that on the actual aluminum. Now, before we actually take this and create the flat pattern, I'm going to add some notes for tabs. And basically the tabs will then be bent up so that we can rivet that to the bumper and to various locations throughout, so that it increases the strength and rigidity of this part, as well as the bumper. As you can see, it moves quite a bit, but if it actually is riveted here and riveted here, it'll actually gain some rigidity. So we'll do that real quick, and then we'll draw out our flat pattern. Alright, so I've laid out the flat pattern on the aluminum. And basically, when I say flat pattern, this is going to be a bent sheet metal part. And flat patterns are the flat of that bent part, which this is right now. Basically what I'm going to do is hold it tight to the aluminum and draw around it with a Sharpie, and then we'll cut to that shape. Keep in mind that all of these are tabs that we're going to actually add on the outside. Alright guys, so we are back. We basically created the flat pattern again. Tabs are added in now, and now we're going to begin cutting it out. Alright, now that it's rough cut out, if you ever noticed, while cutting, this side actually curls up while this side stays flat, and that's because of the way that these are designed. So basically we'll be going around that way to cut it out to keep this as flat as possible. Also, when we drew the line, we actually drew it on the outside, so we'll be cutting to roughly the inside side of the Sharpie to keep it as accurate as possible. Obviously minus these, those are a little different. So now, before I actually bend all these tabs, I'm going to actually create a tear in the aluminum, and that's so that it can bend easier. Normally we would design what is called a relief, so that the parts can actually cut or be bent without distorting the main piece, but these are not water jet cut, so all I can do is create a tear basically. Alright, so this is called a press brake, if you want to consider it that. It's a really cheap one, but it does work with thin sheet metal, so that's what we're going to use. Basically, we're going to bend all these tabs by using various dies. You'll see me do that now. Alright, so I have now marked the final bend right there and there, and this is to bend it so that it actually goes vertical and horizontal, and then we'll get to test fit it. All right, so in the rear, you can see we filled in the giant void that we created by cutting last week. Basically, same ordeal. Take some sheet metal, cut it to shape, and then rivet it in place to the bumper. It actually makes the bumper really rigid. Everything is pretty solid. This is still loose because it's not mounted to our off-the-shelf unit yet. We are going to bolt this to the off-the-shelf unit. We haven't figured out exactly where the off-the-shelf unit is going to land as far as height, so that's why you see this extra bit, and we'll finish that up as we do the flat underbody. You can also see I don't know, these little pieces, these little beauty plates, which kind of clean off the ML24 kit and make it look not like there's a hole there. As far as fit and finish, Clay wants to make it prettier. I told him race cars aren't pretty. He doesn't believe me.
They could be better.
No, they can't. Maybe. All right, so moving to the rear again, we actually got the rear wing mounted. These are 3D printed mounts, so I can't actually really hang from the wing right now. But the uprights are very, very strong. We used FEA, which is finite element analysis, to analyze the uprights, and basically that dictated the entire shape. At 2,000 pounds of downforce, the uprights only move, I think it's 1/4 of a millimeter. So there is very, very little deflection in the uprights, and we're actually really happy about that because you don't lose downforce as you gain speed, which would be bad. You can see that it's mounted to 3 locations per side. The U channel is added for lateral strength, which is left to right. We had to cut a little bit of the trunk to fit the upright properly, but overall it turned out pretty well. We'll probably end up adding some sealant to help aid, but realistically the car will never or rarely see water. A question I saw this week was, I thought you guys said you were doing a dual element. It looks like a single element. Well, that's because we're getting the dual element made. But basically, the dual element will look something like this, and it mounts to our current wing, and then the dual element will actually mount to this, and then this will actually allow the adjustment, which then varies downforce quite significantly. All right, guys, this concludes episode 6. Next week, we will be doing some cooling system work. We'll be doing a little bit more sheet metal work, maybe some welding, not sure yet. And what's the other thing? Oh, we're gonna cut the trunk. Yeah, definitely cut the trunk. Yeah. Do you have any questions, Clay? Clay's gonna be asking some questions.
We talked about it earlier, but my biggest thing is I do like prettiness. Is there anything that we can do to maybe clean up these fender liners a little bit and possibly fill in the little gaps that we have?
We'll probably be taking the, not a die grinder, but some sanding discs and cleaning up the cuts from the cutoff wheel. And then we may use some bonding agent similar to this to fill in the gaps and make it a little bit cleaner. But realistically, this was a down and dirty deal. If we were doing a little bit higher budget, we would actually make maybe a carbon fender that actually comes with a fender liner. And obviously the cost goes up significantly there.
All right, my other question is, I'm very curious, what are we gonna have to do differently to mount the off-the-shelf unit diffuser? I know you said we're gonna mount it to the new aluminum fender liner right here, but is there anything else that we're gonna have to do differently?
No, it uses the front mounting point and it uses the rear mounting points the same as the off-the-shelf. It did lose the outer one, which basically kind of went right here, but otherwise it retains the 2 main ones. We're gonna basically bolt the off-the-shelf unit to this fender right here, and that will give it a little bit more strength vertically, and we should be good there. If we need more strength, it shouldn't be too hard to use some like splitter ties or something to increase the strength.
And if you guys didn't notice, they are running our lower control arms
They have for a while, and our toe links. One other question that I've seen a few times is, I'm surprised that the car only made 100 pounds of downforce, and I figured I would kind of expand on that a little bit, because I guess it does kind of seem unrealistic when you look at the values that the wing and a large front splitter normally put on. So the top of a car actually produces lift, and that's because the car is in essence a very disgusting wing upside down. So the top surface actually has negative pressure and is actually pushing the car up. So all of these areas, the fenders and the wide body, all those locations actually increase the area that lift is acting. And the car itself actually produced about 700 pounds of lift in this form. We basically took out the splitter, the rear wing, the rear diffuser. So we actually can, in CFD, approximate what each part of the car is making as far as lift and downforce. So the units before were actually counteracting 700 pounds of lift. So now our 1,700 pounds of downforce are counteracting that 700 pounds of lift as well. So that's actually 2,400 pounds of downforce that our kit is making. So I hope that kind of clears things up and makes a little bit more sense. But if not, just ask us and we'll try and clear it up again. Thanks for following, and tune in next week.